It's one of those weird facts of life, right? How can the average guess of a massive crowd be so unbelievably accurate? Sometimes it's even better than a single expert. Well, that's the wisdom of crowds, but it doesn't always work. Today, we're diving into a new idea, a hypothesis that says there's a hidden three-step pattern that separates a wise crowd from, well, a foolish one.
So here's our game plan. First, we're going to tackle that central puzzle of crowd intelligence. Then, we'll uncover this proposed three-step pattern that might explain it all. We'll also look at the exact conditions you need for this wisdom to actually show up, see how you could prove the theory wrong, and finally, explore what it all means for everything from markets to public policy.
All right, let's start with the big mystery, the wise crowd paradox. It's this completely counterintuitive idea that a whole group of regular people can somehow come up with a better answer than almost any single super-informed expert.
I'm sure you've heard of the classic experiment, guessing the number of marbles in a jar. It happens over and over again. Most people's guesses are way off. But when you average all those guesses together, the result is often spookily close to the real number. So how on earth is that possible? Is it just some statistical fluke, or is there something much deeper going on?
But here's the catch. For every amazing story about a wise crowd, you've got a cautionary tale about a foolish one. We've all seen groupthink lead to terrible decisions. We've seen financial bubbles where the collective gets it disastrously wrong. So the real question is, what's the difference? What separates the wise crowd that cancels out all the noise from the foolish one that just makes it louder?
And that question brings us to a new hypothesis that points to a hidden pattern behind all of this. It suggests that crowd wisdom isn't just a happy accident. It's actually a very structured process. So what does that process look like?
Well, the idea is called the THD hypothesis, and it asks us to stop thinking of a crowd as just a bunch of people and start thinking of it as an information processing system. This system, the theory goes, moves through three very specific phases that work together to filter out all the random individual mistakes and pull out the correct answer, the signal, from all that noise.
And it's really important to note, this idea doesn't come from nowhere. The hypothesis is actually built on a bigger framework called informational physics, which was developed by the researcher and author Kevin L. Brown. It's all about applying principles from physics to understand how information itself behaves. Okay, so let's break down this process. It all starts with what's called the base phase. Pretty simple. Everyone makes their own independent guess. Then comes the pressure phase. This is where all the disagreement, the different guesses, creates a kind of informational pressure. And finally, you get the integration phase. This is where the magic really happens. The system averages out all those conflicting views, and in doing so, the random errors cancel each other out, revealing the right answer hiding underneath.
So, to put it really simply, people guess. Their guesses are all over the place, and the system then integrates all that disagreement into one single, shockingly accurate answer. The crowd doesn't get smart because everyone figures out the truth. It gets smart because their combined mistakes are organized in just the right way to be filtered out.
But, and this is a really big but, this process doesn't just happen on its own. It needs some very specific conditions to be in place. This isn't magic, it's all about having the right structure for the information to flow correctly. Which leads us to the next obvious question, right? What exactly are those conditions? What are the key ingredients you need to turn a bunch of wrong answers into a right one?
This is where the theory gets really practical. You see, it identifies a few crucial things. First, you need good error dispersion. That's just a fancy way of saying you need a wide variety of guesses, some too high, some too low. Next, the independence level is absolutely critical. People can't be copying each other's answers. And finally, you need to keep shared bias low. If everybody is wrong in the exact same way, the system just collapses. So in other words, diversity and independence aren't just feel-good ideas, they are mathematical requirements for a crowd to be smart.
Now, for any new idea to be taken seriously, especially in science, you have to be able to test it. And even more importantly, you have to be able to say, here's how you could prove me wrong. This is what's known as falsification.
So you might be thinking, okay, this is a cool story, but is it a real scientific theory? Can you actually test it? And the answer is a definite yes, because the theory comes with very clear conditions for failure.
This lays it out perfectly. You could prove the hypothesis wrong if, for example, you set up all the right conditions, lots of diverse, independent guesses, but the crowd's final answer is still no better than any random person's guess. Or if a group where everyone thinks for themselves doesn't do any better than a group that's just following a leader.
These are clear, measurable things that would completely undermine the theory.
And this quote just sums it all up. The test is really simple. When you have the right conditions, does the crowd's average mistake consistently end up being smaller than the average individual's mistake? If the answer is yes, the model gets stronger. If it's no, the model is weakened or even proven false. It's as simple as that.
Okay, so we've talked about marbles and theories, but why does any of this actually matter in the real world? Well, this is where it gets really exciting, because understanding this could change everything from how we predict elections to how we forecast the stock market.
I mean, think about it. If this hypothesis is right, the implications are huge. Instead of just crossing our fingers and hoping a crowd is wise, we could actually start to predict when it will be. We could design better polling systems for politics, create more reliable expert panels to guide policy, and even engineer better AIs by combining many different models into one smarter system. It's basically a blueprint for building collective intelligence on purpose.
And that leaves us with one last really powerful question. What if we could go beyond just watching the wisdom of crowds happen and actually start to engineer it? What if we could reliably create the conditions for any group to be smarter than its smartest member? The potential to solve some of the world's most complex problems would be, well, absolutely incredible.